Okay, we've got this right circular cylinder, which looks like this. And we're talking about the surface area, total surface area. How fast is it changing when it's given that the radius is changing at 1 inch per second and the height is changing at 3 inches per second? And we want to know what the rate of change of the surface area, total surface area, is when the height is, when the radius is 20 and the height is 50. Okay, so here is the way that this formula is normally presented. If you picture this cylinder being slit along a height and then laid open flat, this distance right here for this rectangle is 2 pi times the radius, because it's really the circumference of the circle. And of course, h is the height. So 2 pi rh, that's the surface area of the curved part. And 2 pi r squared is the area of one of the bases, but there's two bases. So it's probably easier to take the derivative if you factor out the 2 pi. And we're left with RH plus r squared on the inside. So when we take the derivative with respect to time, ds dt equals 2 pi times the derivative of this. And for this term right here, we have to use the product rule. So the derivative of the first times the second plus the second, plus the first times the derivative of the second. And finally, for 2r squared, it's 2r times dr dt, applying the chain rule. And at that point, we've got a formula for the derivative of the surface area with respect to time. Just substitute what you know. I put the units in here for emphasis, because when you take 1 inch squared per second times 50 inches, you get inches squared per second, which is the rate of change of surface area, inches squared per second. And if you multiply these all out, add them together, you get 290 on the inside, multiplied by 2 pi, 580 pi inches squared per second is the rate of change of the total surface area at a particular point in time when r is 20 inches and h is 50. I just included this to show you what the total surface area is at that point in time, but it has nothing to do with the problem. There you go. Hope that helped. If you have any questions, post a comment.